In this video, we will discuss how to create a custom part from scratch for flux.ai. As an example, I am going to show you how to add Seeeduino Xiao on Flex. Before that, we actually need two things: SVG file of the symbol and also the 3D model of the component. We are using a model I actually found from GrabCAD, and also the 3D file actually need to be .step file. We are going to design the symbol using Inkscape. It is a vector designing software. You can see that I already designed the symbol in it. The main thing to consider when designing a symbol is that the stroke width always need to be 1 pixel. Also, the background need to be transparent. After designing, we can actually export this to .svg file. Now we are using Flex. You can rename the project by the name of the component. Since our board has 14 pins, we can start by dragging one terminal from the part library to the workspace and copy and paste the terminal 13 times. Next, we will import SVG file of the symbol. For that, we can go to the Assets section and click Add and select Add Item and choose our SVG file. After that, we need to find the wire snapping points. For that, first we are going to publish this component to the component library. After publishing our component, open a new blank project and search for the component in the search bar and drag it to our workspace and wait for the symbol to appear. After that, we will change the X and Y position to 0. This will move the symbol to the center of the workspace. Next, add one terminal and place it on the pins. Wire snapping position is on the center of the terminal line. So put the terminal center into the end of the symbol pin. This technique is used to find the wire snap X and Y position easily. Copy the X and Y values of the terminal position and paste it on the similar position on our main component page. And you have to do the same thing to all pins. Also put the number of the pins. After publishing the component, once again we update the component on the other example project. If everything is good, all the wire snapping point and names will be visible. Now let's add some documentation for this component. First, we need to find an image for the component. It is better to find if you have like a PNG file with a transparent background. You can add this through Asset tab and also set it as thumbnail. Next, we can add a short description about the component. On Property tab, you can add the designator, prefix, manufacturing part number, also the URLs of purchase link and datasheet. You can find the manufacturer part number from the product page of the component. Now let's make a PCB footprint for the component. You can do this in two ways: by importing a KiCad footprint file. Also, you can do it manually. Okay, now we are on PCB workspace. You can see that all the footprint will be seen as a single spot. You can drag each and every footprint and edit its position, size, hole size, etc. Another way is by importing an existing KiCad footprint. I found this KiCad file of the shower from the Seeeduino wiki page. The footprint file will be KiCad mode. To import this to the Flex, add this file as an asset and select the footprint under the root and add an object specific rule and select and add the asset. Sometimes it is not that perfect, so you just need to move around the pin into the correct position. Now let's talk about how to import the 3D model of the component. First, we need to import the 3D model as an asset to our project and then click on three dots on the footprint and add model now. Add an asset rule and select our 3D model. Now you can go to the 3D view. The 3D model will be visible. To rotate our model to the right orientation, we need to add a rotation rule in object specific rule. You can control the X, Y, and Z rotation in it. You can move around the component to the right position using your keyboard. So we are done with all of our steps. Now you can actually publish this to the Flex library and start working with it. I think you got a basic idea of how to import a custom component to Flex. So thanks for watching this video. Happy making.